This is number 24 from our chapter 14 on correlation and regression. So we're asked to compute the Pearson correlation for these sets of pairs of numbers, as well as to determine the line of the best fit, the formula for the line of best fit. So in order to do that, we're going to use these following formulas. So this is for the correlation part. We're going to do R equals the sum of products over the square root of the sum of squares x times the sum of squares y. For the sum of products, we're going to use the computational version of it. So that's the sum of the xy column minus the quantity of the sum of x times the quantity of the sum of y over n pairs of data. And for the sum of squares x, we'll use the sum of x squared minus the sum of x quantity squared over n. And for y, the sum of y squared minus the sum of quantity y squared over n. So every time that we see one of these summation notes, that's pretty much another place where you can add a column to the table. So let's go ahead and just add these 3 columns to our table because we know we're going to use them anyway. So we'll do the xy, the x squared, and the y squared. All right, so x times y, 1 times 0, that's 0, 20, 0, 3 times 14, that's 42, 24, and this is 64. Oh, we could even probably just find the summation of these two very quickly. So 2, 3, 6, 8, 12. And this is 10, 18, 60. Okay, so then the x times y column, 0. That's 20, 62, 82, 86. It's 150. So let's fill out the x squared column. That's 1, 4, 0, 9, 4, 16. And now we're going to square all of the y column. 0, 100, 64, 14 squared is 196. 196 and 12 squared is 144. 16 squared is 256. And then we can add up the sum of the x squared and the sum of the y squared. So that's 34 and 760 for this one. So now we have everything that we need. Right? So we have all the information we need, so let's just start plugging in. Right? So let's figure out what the sum of products is. So let's do the sum of products first. Sum of products equals, so that's the sum of the xy column minus the sum of the x column. That's 12 times 60 over 1, 2, 3, 4, 5, 6 pairs. So that ends up being 150 minus, that works out to 120. So the sum of products is 30. Okay, so we got the sum of products. Let's do the sum of x. So the sum of squares x. So that is, we're going to use the sum of the x squared column, and then we're going to subtract this quantity squared over n. So that's 34 minus 12 squared over 6. So that equals 34 minus 12 squared over 6. That is 24 divided by 6. 24. And sum of squares x equals 10. Now we're going to do the sum of squares y. Y equals 760 minus 60 squared over 6. 60, 600, so 100. Oops, 160. Let me actually write that over here. 160. Okay, so we have everything that we need now to figure out the correlation. So let's do R. Let's do R right here. Sum of products is 30 over square root of sum of squares x, which is 10, times sum of squares y, which is 160. So then that is 30 over the square root of 1600, which is 30 over, and this is just 40 squared. So then these two undo each other. So we have 30 over 40, which is 3 over 4, or 0.75. So R equals 0.75. So that was correlation. So let's find the line, which is the line of best fit, right? Bx plus A. So we need to find B and A. B is sum of products over sum of squares of x. So that is 30 over 10. So that's 3. And A is equal to, that is the mean of y minus B times the mean of x. So we need to find the mean of x and the mean of y for this one. So if we go up here, x was 12, so that's 12 divided by 6, so that's 2, right? So the mean of x is 2. So we know that this is 2. We know that b is 3. And then we just need the mean of y. So that's 60 divided by 6, so that's 10. The mean of y is 10. So we have that A is equal to 10 minus 6. So that's 4. Okay, so we have A equals 4 and B equals 3. So we have that the line of best fit is defined by 3x plus 4. So that's the line of best fit.